Okay, today we're going to look at section 8.2, visualizing data. If the data we're visualizing is categorical, then we want a quick way to represent graphically the relation or the relative numbers of units that fall in each category. Frequencies are nice when we're organizing and summarizing data. They're easy to compute and they're always whole numbers. We often summarize categorical data not with frequencies but with proportions. The proportion of the data that falls into a particular category is computed by dividing the frequency for that category by the total number of units in the data. The proportion of a category is category frequency over total number of data units. Proportions can be expressed as fractions, decimals, or percentages. The sum of all the proportions for all categories should be 1 if you're using fractions and decimals, or 100% if you're using percentages. Keep in mind, however, if you round off the results of the computations to get your percentages or decimals, the sum might not exactly equal 1 or 100 in the end due to the rounding area. So we go back to our students and their majors. So let's see, we had undecided, political science, biology, sociology, and education. Is that all of them? I think so. And let's see, undecided was 1, 2, 3, 4. Political science was 1, 2, 3. Biology 1, 2, 3, 4, 5, 6. Sociology 1, 2. And education was 1. 4 plus 3 is 7, 13, 15, 16. So we have a total here of 16. All right, this was the category, this was the frequency, and this is the proportion. So it is simply 4 over 16, 3 over 16, 6 over 16, 2 over 16, and 1 over 16. That would be our proportions. The frequency over the total. Now you can use your calculator and turn those into decimals, then multiply that by 100 to get percentages. But at this point, why not just leave it as that simple fraction? And since everything's over 16, we have 4 plus 3 plus 6 plus 2 plus 1, which is 16. So it equals 16 over 16, which is 1. Another visualization category we use is a bar chart. This consists of a series of rectangles arranged side by side but not touching. Each rectangle corresponds to one of the categories. All the rectangles have the same width. The height of each rectangle corresponds to either the number of units in a corresponding category or the proportion of the total units that fall into the category. So let's see, what was our categories here? We had undecided. I'm just going to go UD. And then we had bio, social, uh, political science, political science, bio, social, and ed. And we had 43621. Just making a note, 43621. So across the bottom is our categories. Over here, I'm going to go 2, 4, and 6. We had 4 here, so I just create a rectangle. We had 3 here. Nope, it goes to 4. Typically, to cut back on confusion, I put the frequency above. I don't have to, but it is helpful. Here we had political science with 3. Here we had biology with 6. Here we had social science with 2. And here we had ed with 1. And there we are. So we have an example here. Yeah. Bar, the bar graph shows the region of every institution of higher learning in the United States, except for the service academies like West Point. So here's what we're looking at. Now we want to analyze the bar chart to answer the following question. Which region contains the largest number of institutions of highest learning? So whose bar is highest? Southeast. What proportion of all institutions of higher learning can be found in the Southwest? Well, we're lucky because we're given percentages, which is proportions. So we go to Southwest, that's here, which is roughly 10%. Okay? And which regions have under 5% of the total number of institutes of higher learning? Well, here's our 5% line. I have outlying areas in Rocky Mountains. Outlying areas, which makes sense, in Rocky Mountains. I can't imagine many universities in outlying areas or in the middle of the Rocky Mountains. So that's how we can use our bar chart to get information. Next is something you might possibly have seen. A pie chart consists of a circle divided in wedges, with each wedge corresponding to a category. The proportion of the area of the entire circle that each wedge represents corresponds to the proportion of the data in the category. So here are our information on biology. They used a proportion. They went through and did decimals. Now, pie charts are difficult to do by hand. Um, they can be done fairly easily with something like Excel. That's what I use to create this. Where'd it go? There it is. So as you can see, the wedges represent the size, 38% roughly, 25% roughly for undecided. And that's how it works. Sometimes you'll have a key telling you what each color is. Sometimes it might just say in here, biology, undecided, depending on how it's made. So that brings us to our next example, which is called a stem and leaf plot. This is a visualization tool that falls somewhere between a list of all the raw data and a graph. Stem leaf plot consists of a list of stems on the left and the corresponding leaves on the right, separated by a line. The stems are the numbers that make up the data only up to the last digit, and the leaves are the final digits. There is one leaf for each data value, which means that the leaves may be repeated, and the leaves should be evenly spaced across all stems. These plots are really nothing more than a fancy way of listing all the raw data. As a result, they shouldn't be used to visualize large data sets. So let's look at this stem leaf plot below, which represents data collected from a sample of employed people who were asked how far in miles they commute each day. So here's how this works before we go on. The stem is the first digit. Each of these leaves count as a different data point. So this first row here is the number 4, or 4, 6, and 7. That's what the 0 and this means. Yep, maybe I'll go ahead and leave that. 4, 6, and 7. Okay, so that means this has just 3 data points in it. So how many data points are represented? Well, I have one number here that's 60, right? So that's 1. Same here. There's 0 here. Now here I have a 30, a 30, a 35, a 35, and a 36. So there's 5 data points there. This is 20, 25, and 25, and 25. That's 4 data points. And this is 10, 10, 10, 12, 12, 12, 14, 15, 18, 18, 36. And that's 10. So how many data points do I have? 13, 17, 22, 23, 24. So I have 24. What are the 3 longest and shortest commutes? So, well, the longest one is 60. The next longest one is 50. And the next longest one is this 36. And then from shortest, we have 4, 6, and 7. The full list of data. Okay, so we go through our list here. We have 4, 6, 7, 10, 10, 10, 12, 12, 12, 14, 15, 18, 18, 20, 25, 25, 25, 30, 30, 35, 35, 36, 50, and 60. So it kind of, if you turn it on its side, it kind of represents a bar chart. You know, here's a bar from 0 to 9, a bend bar chart. And then from 10 to 19, 20 to 29, 30 to 39, nothing here, and then 50 to 59, and 60 to 69. So if you turn that sideways, you can kind of see the chart, a bar chart to some degree. So you can get you can look at a frequency distribution in that fashion as well. Stem and leaf plots are useful in that they give us a sense of the shape of the data. Well, there we are. Are the data evenly spread out over the stems, or are some stems heavier with leaves? Are the heavy stems on the low side, the high side, or somewhere in the middle? These questions about the distribution of the data or how the data are spread out over the range of possible values. Some words we use to describe distributions are uniform, where the data is equal distributed across the range. Symmetric, data are bunched up in the middle and taper off in the same way above and below the middle. Left skewed, the data are bunched up on the high end or the larger values and taper off towards the low end or smaller values. And right skewed, where the data are bunched up at the low end and taper off towards the high end. So this table gives the records of Major League Baseball teams at the end of the 2019 season. We're going to create a stem leaf. So our stem contains all but the last digits. Now these are in order for us. And we're doing wins. So our first stem is 1, 0. Then I have a 9, right here, 9, and 8, and 7, and 6, and 5, and 4. That's my stems. So now I look at my leaves. Here I have 7. Oops, going the wrong way. 6, 3, and 1. 7, 6, 3, and 1. Here I have, typically we like to go smallest to largest. So 1, 3, 6, and 7. Now here, my 90s, I have a 1, I have a 3, I have another 3, I have a 6, and I have 2 sevens. In my 80s, my lowest 80 is an 81. Then I have two 84s, an 85, an 86, and an 89 right there. Then I have my lowest 70 is a 70. So 0, 1, 2, 2, 5, 7, 8. 0, 1, 2, 2, 5, 7, 8. Then looking at my 60s, I have a 67, a 68, and a 69. Going to my 50s, I have a 54, 57, and 59, and I have a 47. And there is our stem leaf. Remember, the leaf is only one digit. So if there's 3 digits in the number, the stem is going to be the first 2. Next thing we look at is histograms, which are visualizations that can be used for any set of quantitative data, no matter how big or spread out. They differ from a categorical bar chart in that the horizontal axis is labeled with numbers, not ranges of numbers, and the bars are drawn so that they touch each other. The heights of the bars reflect the frequencies in each bin. Unlike with stem leaf plots, we cannot recreate the original data set from a histogram. We just made a stem leaf plot of the number of wins for each major league team. Using that set of data, create a histogram for the number of wins. Use bins with widths of 10. So I'm going to go over here. And we can start at 40. There. 49. 59. 69. 79. 89. 99. And 109. That's going to present a problem. That's not what our bins were. Let's go back. Try that again. So we'll go 40, 50, 60, 70, 80, 90, 100, 110. Okay, that's our number line. Okay, then we go up here like this. And then we look, how many people, how many teams? We'll go 2, 4, 6, and 8 should be enough. Now, how many teams had between 40 and 50? 40, but less than 50. There was 1. And again, I make a note of how many. That way, if my drawing's a little off, it's not a big deal. From 50 to just below 60 is 3. From 60 to almost 70 is 3 as well. Then the 70 to 80 range, 1, 2, 3, 4, 5, 6, 7. And we're going up here to 7. And the 80 range, 2, 4, 6. 90 range is 6 as well. And then we had 4 teams between 100 and 110. Note the bars touch. It's a continuous number line. This bin is from 40 to just below 50. This bin starts at 50 and it ends just below 60. And so forth. So be careful of that. Okay, then we have an issue with graphs. Graphical representations of data can be manipulated in ways that intentionally mislead the reader. There are two primary ways this can be done: by manipulating the scales on the axes and by manipulating or misrepresenting areas of the bars. So here we have top 5 EPL teams by payroll for January 2020. Looks pretty simple. Looks like these 4 are pretty much the same. Now, what if we do this and change our scale? Now they don't look so much the same. What happened here? Instead of starting at 0, we started at 120. So beware of the vertical axis that don't start at 0. They overemphasize differences in height. So remember, these 4 pretty much looked identical in the previous one. Now you can see a significant difference. And this one here, it looks 3 times as big, and it's not. Okay, here we have graphical representations or infographics. These areas overemphasize the difference that should be measured in height. So we're not measuring the area, we're measuring the height. So again, and this has that 120 scale, so it still doesn't look all that great. But if you look, this one's about 130. This one's about 135. However, if you're looking at the area, it looks to have almost twice as much area. And then we won't even get started with this one. So be careful of these things. All right. Okay, so here we have payroll in millions of pounds, frequency versus payroll. Always check the horizontal axis on a histogram. The widths of all the bars should be the same. So here they are. They're 40 each. Here, 40, 40. Who knows how much? It looks like it went to 200. So that last bar represents like 120 different. Because the information went to 200 here. So this would be 80 to 200, covering 3 times as much. So make sure to check the horizontal axis on histogram. This is the way these things are used to mislead people. So that finishes up the lecture on section 8.2.